Welcome back. We are on to Chapter 3. Can you believe we made it this far already? So quick reminder, please like and subscribe if you are enjoying this content. It really helps me out, helps spread this course to others that are looking for the same thing. So again, I would appreciate that. So we will go ahead and start with our chapter warm-up, this 24 game. If you don't want to do this, I have all the chapters down below. You can go ahead and just click on to the next chapter. But as a reminder, how this game works is you use these four numbers. You can add, subtract, multiply, or divide, and you're going to try to get to 24 with these four numbers. So if you feel like it, go ahead and pause and see if you can come up with some solutions to these. All right, so here's what I got. So the first one, you can do 3 times 3 would be 9, times 3 is 27, minus 3 would be 24. Second one here, you could do 3 times 5 would be 15, minus 7 would be 8, times 3 would be 24. This next one here, you could do 7 minus 3 would be 4, times 4 would be 16, plus 8 would be 24. This last one here, this one's tricky. This one took a little while to see it, but and there might be multiple answers. But the one that I found was 5 times 13 would be 65, plus 7 would be 72, divided by 3 is 24. Is that right? Let's see, 24 times 3, we're looking for 72, so this is 12, 3 times 4, and then 3 times 20 would be 60, and yeah, that would be 72. All right, yeah, that was a tough one though. So, moving on to 3.1, multiples. So, for multiples, first of all, we know that 3 times 4 is going to equal 12, and that means that something times 4 is 12. Some integer times 4 is 12. So that means that 12 is a multiple of 4. So 4 is a multiple of 4, 8 is a multiple of 4, 12, 16, 20, 24, everything that you can make with 4, with multiplication, is a multiple. So 12 is also a multiple of some other numbers too, like 1. You can do 1 times 12 to make 12. 3 is a multiple of 12, 3 times 4. 6 is a multiple of 12. You can do 6 times 2 to get 12. And 12 is a multiple of 12, 12 times 1. Negative 12 is also a multiple of 4 because you can still get to negative 12 starting from 4. So if you're at 4 and you multiply negative 3, then you get negative 12. So you can still make negative 12 with positive 4. So negative 12 is a multiple of 4. 0 is going to be a multiple of every number because you can always make 0. So, 40 billion times 0, you get 0. So you can always make 0. So in this chapter, we're going to revert back to maybe how you used to think about division prior to chapter 1. If you remember chapter 1, a lot of our exercises, we would switch division into multiplication. We'd multiply the reciprocal. So we're going to go back to thinking about division with a quotient and a remainder. Both are correct. Not, one isn't better than the other, but depending on what you're trying to do, one method might make more sense than the other. So in this case, when talking about multiples, it's a little bit nicer to think of division with a quotient and remainder because that's what we can do as a test. To find out if something is a multiple, you can use division. And if it has no remainder, that means that it's a multiple. So if you were to do 12 divided by 4, you know that that has no remainder. 12 divided by 4 is 3 with 0 remainder. So that means it is a multiple. So if you ever need to do a test to see if something is a multiple of a number, you can just use division and make sure that it has 0 remainder. If it does have a remainder, it's not a multiple. 0 is divisible by every non-zero integer. You can't divide by 0, but if you did 0 divided by anything, you get 0. So that's why 0 is a multiple of everything. Okay, jumping into problem 3.1, go ahead and pause this and see if you can come up with answers to these questions here, and then we'll go over them. All right, so first of all, we have a video right here, link in the description as always, so go ahead and check that out. It's always nice to hear something explained in a different way, maybe using different words, and maybe it really sinks in. So I always recommend watching these videos, even if it's stuff that we've already covered. All right, so let's get into it. So both 147 and 357 are multiples of 7. Is 147 plus 357 a multiple of 7? Okay, well, let's see. So 147 plus 357. What's that going to be? All right, 7 to 7 is 14. 14. That's going to be 10. And that's going to be 5. So 504 is 504 divided by 7. And will this give us a remainder of 0? If it gives us a remainder of 0, then it is a multiple of 7. All right, so 7 doesn't go into 5, but 7 can go into 50 7 times, or 70, to be 490. All right, so 4 minus 0 would be 4. 50 minus 49 would be 1. Okay, so 14. 7 goes into 14 2 times. So 2 times 7 is 14, and we have a remainder of 0. So that means that that is a multiple of 7. So that's good to know. If we have a multiple of 7 and add it to another multiple of 7, then we get another multiple of 7. All right, so B, suppose that k is a multiple of 7. Must k plus 7 also be a multiple of 7? Well, let's see how we can approach this. So let's say k is equal to, let's say 14. That's a multiple of 7, right? So k plus 7 would equal 21. Well, that's a multiple of 7 also. What if k was 21? Then k plus 7 would be 28, and that's another multiple of 7. So it seems to check out. So let's kind of abstract this and see if we can do a rudimentary proof for this. So if k is a multiple of 7, then we know that k has to be 7 times some integer, right? Like, for example, if k is 14, then we know that k is 7 times 2. If k is 21, then we know that k is 7 times 3. If k is negative 21, we know that k is 7 times negative 3. But it has to be times some integer. We know it's a multiple of 7, so it has to be 7 times something. All right, so we know that. So if we have k plus 7, that would be 7a plus 7. All right, and we can actually factor out the 7 here. If we treat this 7 here as 7 times 1, and we can do the reverse of the distributive property. So we can pull out the 7 and factor that out, and we're left with a plus 1. Okay, well, if we do this, this is going to go into, this can be divided by 7 with no remainder. It would just be, it would just leave a plus 1 if you divided 7 out of that. So that looks good, and this is going to be an integer, right? So if we divide by 7, we're going to be left with whatever a is plus 1. So that seems to work out. It's always going to have no remainder. So that would be a multiple of 7. All right, now C. Suppose R and S are multiples of 7. Must R plus S be a multiple of 7? Now we're kind of getting the idea at this point, and we could probably just assume that this will also be the case, but let's go ahead and check it. So R, just like K, must be, it's a multiple of 7, so it must be 7 times something. Let's just say A. And S is also going to be 7 times something. We'll say 7b, because it could be a different integer, right? So R plus S is going to be 7a plus 7b. And now the same thing, we can go and factor out the 7. So 7a plus b. Remember, a and b are both integers. So when we divide by 7, then the 7s will cancel out, and we'll be left with whatever a plus b is. But it'll be no remainder. So that will also be a multiple of 7. Okay, so now suppose k is a multiple of 7. Is it possible for k plus 23 to be a multiple of 7? Well, at this point, you probably know that this is not going to be a multiple of 7. But let's see if we can find a reason for that. So let's say k is 0. Let's just set k equal to 0, which is a multiple of 7. Well, if we did k plus 21, that would be 0 plus 21. It would be just 21, right? That would be a multiple of 7. That would be a multiple of 7. And what would be the next multiple of 7? Well, you just add 7 to that. So k plus 28 would be a multiple of 7. But there's nothing in between. There is no number between 21 and 28. That would be a multiple of 7. And that works for any value of k. So we started at 0 just to make it easy so that we can very easily see that these are multiples of 7. But if we started at, say, 21, and this would be 42, that's another multiple of 7. It's just shifting the multiple of 7. But there will never be a case when k plus 23 is a multiple of 7, assuming that k is a multiple of 7. So this is not the case. Here's an important note here. If a and b are multiples of c, then both a plus b and a minus b, what did I say c? I meant a plus b and a minus b are both going to be multiples of 7. So we didn't talk about this one here, but that's going to be also true. So if a and b are multiples of 7, then a minus b will also be a multiple of 7. All right, give this one a shot. So what number between 100 and 200 is both a perfect square and a multiple of 7? All right, so there is a warning also. When it says between 100 and 200, that will, in this book, not include the numbers on the outside. So in this case, it will not include 100 and 200. So 10 squared we'll throw out because then that would be 100. So let's see, 11 squared would be 121. 12 squared is 144. 13 squared is 169. 14 squared would be 196. And I think it's pretty safe to assume that 15 squared is going to be over 200. Okay, so which of these would be multiples of 7? Well, we can just try them all. Let's try 121 divided by 7. So let's see. This can go into 12 only one time. So let's say 10. We'll start there. It's 70. That's be 51. 51. There we go. All right, so 51. I think we can do 7 more times. So that would be 49. And 2. All right, so we have a remainder there. So that'd be 17 with a remainder of 2. So that one is not a multiple of 7. All right, how about 144? Well, I see a 14 here. That's a pretty good start, right? So 7 goes into 14 2 times. Let's try 20. Be 140. I think you already can probably see this is not going to work here because now we have a remainder of 4. All right, so that's not. How about 169 divided by 7? Again, let's do 20 here. So that would be 140. And let's see, we've got 29. How many more can we do? Let's do 4 more. 7 times 4 is 28. Oh, close. Remainder of 1, so that's not. All right, so 196, our last chance. 196. All right, so let's do 20 once again. That'll be 140. Let's see, so we got 6, we got 5, 56. Oh, 56, that's a multiple of 7, right? Plus 8 to be 56. All right, so there we go. 196 would be a perfect square between 100 and 200 and a multiple of 7. Okay, what is the greatest 3-digit number that is a multiple of 13? Go ahead and give that one a shot. Well, this one's kind of a tricky one. So there's a couple of ways that we can go about solving this one. One of them is like this. So the greatest 3-digit number is 999. Well, I wonder if this just, maybe we'll get lucky. Maybe this is a multiple of 13. Let's give this a shot. So how many times does 13 go into 99? I'm not sure. Let's try 70. So this would be, let's see, 21, be 91, or 910. And so this would give us 9 and an 8. All right, for 89, let's try, let's see, 7. We just did 7. That gave us 91, so that was too many. So let's try 6. So that would be 18 and 7. Okay, so that would give us a remainder of 11. Well, it's not a multiple of 13, but now I'm curious. If instead of doing 999, what if we had done 998? Then after this first round of subtraction, that would have left us with 88. And minusing 78, that would leave us with a remainder of 10. And if we had tried 997, that would have left us with a remainder of 9. And to see where we're going, if we keep on working backwards, ultimately we'll get to a number with a remainder of 0. So what if we did 999 minus 11, because that's what a remainder was. It should get us to a number with a remainder of 0, and that would give us 988. All right, so that's one way to go about it. Another way to go about it would be doing something like, well, we know 1300 is a multiple of 13, but that's a 4-digit number. We also know that 130 is a multiple of 13. That's a 3-digit number. But something we talked about a couple slides ago is if A is a multiple of 13 in this case, and B is a multiple of 13, A minus B is also a multiple of 13. So that means 1300 minus 130 would also be a multiple of 13. Let's see what this is. So this is going to be 2, 10, 9. No, we didn't need to do that. So let's undo that and say 0. We have a 7 and a 1 and a 1. 1170. Okay, so that's still higher than a 3-digit number. So let's just do it again. Minus 130 again. So we have 0, we have 4, and we have 10. 1040. Okay, so we're getting closer. Probably don't want to subtract 130 because that would be too much. Now I can just try subtracting 13s. How many 13s? Well, we know 2 13s would be 26. 3 13s would be 39. Ooh, that would be real close, right? So let's do 4 13s. What would 4 13s be? So 13 times 4 would be 12 and 5, 52. So if we subtract 52, then we would get, let's see here, we need to make this a 9, 14, and 13, and 10. All right, so this will give us an 8. This would give us an 8, and this would give us a 9. And look at that. We have our 988 again. So that's 2 different ways to do this. But this one was a little bit tricky, so if you didn't find that, that's okay. All right, so now how many integers between 2 and 1004 are multiples of 5? And how many integers between 150 and 300 are multiples of 9? So go ahead and see if you can figure out a way to do these. Okay, so we know that the multiples of 5 between 2 and 1004 are, for example, 5, 10, 15, 20, all the way up to 1000. So how many numbers are that? How many numbers is that? Okay, so let's express these in terms of a number times 5. So 5, the first multiple of 5 would be 5. And that's going to be 1 times 5 is going to be 5, right? And then 2 times 5 would be the next multiple of 5. That would be 10. And then 3 times 5, and so on. And that's going to go all the way up to 1,000 is the last number. But instead of calling it 1,000, what is 5? 5 times what would be 1,000? That would be 200. So let's do 200 times 5? Well, so how many numbers are there between, or how many multiples of 5 between 2 and 1,004? Well, 200. Because we started at 1 and we went up to 200. Okay, so this one right here, how many multiples of 9 between 150 and 300? I'm not sure if we can use the same trick for this one. Well, let's just ignore this side of it. Let's see how many multiples of 9 there are up to 300. So let's say there, same trick we did before. So 1 times 9 would be 9. 2 times 9 would be 18, and so on, and up until 300. So 300 divided by 9 would be what? 300 divided by 9. Let's do 30 here. That would be 270. This would leave us with 30 there, and add 3 there, and this would be 27. A remainder of 3. But it's, and that would be 300. So we're not going to go all the way up to 300, but 33 would be our closest. So it would be 33 times 9 would be our last one. And that would give us something a little bit under 300. But that would give us our very last multiple of 9. So that would be 33 times 9. So we know that there are 33 multiples of 9 between 0 and 300. Or between 1 and 300, not including 0, because 0 is also a multiple of 9. So now we just need to remove the ones that are less than 150. So now we can find out how many are up to 150. So we can do the same thing. So 150 divided by 9. So let's see, that can go in 10 times. That would be 90. This would leave us with 60. And so if we do plus 6 would give us 54 with a remainder of 6. So 16. It looks like that would be 16 here. 16 times 9. And that would be actually a little bit less than 150. So that's what we would need to take out. We need to take out those first 16. So 30, oops, not 133, just 33 minus 16 would give us, let's see, borrow from there, 13, that would be 17. So 17 numbers between 150 and 300. So it was a little bit messy, but hopefully all of that made sense. So if you struggle with a problem like this, try to break it down into parts and do what you can do, and just take it one step at a time, and hopefully you can get there. So that one, again, kind of 2 problems in a row that were a little bit tricky. All right, must every multiple of 15 also be a multiple of 3? And must every multiple of 3 also be a multiple of 15? All right, let's think about that. So we know that, so what are the multiples of 15? So 15 is a multiple of 15. 30, 45, 60, 75, and are all these multiples of 3? Well, 15 is. 3 times 5 is 15. Of course, 30 is. Well, 30 plus 15 is 45, so we know that's a multiple of 3. 60 is going to be a multiple of 3, because 6 is. So it's looking like, yeah, all multiples of 15 will also be a multiple of 3. So let's say that M, we'll kind of abstract this and do more of a thorough proof of this. Let's say M is a multiple of 15, so which means that M has to be 15 times some number, just like we did with K a few problems ago. We know that if M is a multiple of 15, then it has to be 15 times something, even if it's 15 times 1 or 15 times 0. It has to be 15 times something if it's a multiple of 15. All right, so we know also that 15 is equal to 3 times 5. So we can write this instead as m is equal to 3 times 5 times n, which means that m is 3 times the integer 5n. So m is also going to be a multiple of 3, because if you divide this by 3, you'll always get 5n. You'll always get a remainder of 0. Every time you divide by 3, you'll get a remainder of 0, and what you'll be left with is whatever 5n was. And n again was whatever integer you're using to multiply by 15. So let's say the number was 3. So m is 45. 45 is 15 times 3. So when you break it out like this, and you divide by 3, you're left with that 5 times 3, which would be 15. So that 45 divided by 3 would be 15, where if you were to divide out 15, then that n would be 3. So I know that was kind of a roundabout way of saying that, yes, it is true that every multiple of 15 will always be a multiple of 3 also. Okay, now must every multiple of 3 also be a multiple of 15? Well, we can probably pretty quickly find that out. So what are the multiples of 3? 3, 6, 9. So is 6 a multiple of 15? No way. You can't get to 6 starting from 15 unless you multiply by a fraction or something like that. But that's not what we consider a multiple. A multiple has to be multiplying by an integer or divisible with no remainder. So and you cannot make 6 starting from 15. 9 is not a multiple of 15. 12 is not a multiple of 15. 15 is, but we can easily say that not every multiple of 3 will also be a multiple of 15. All right, if A is a multiple of B, then every multiple of A is also a multiple of B. And that's it. We made it. I know, that was a tough section. This is possibly the hardest section we've gone through so far. I know as we advance through these chapters and lessons, it's getting a little bit tricky, but this is going into algebra, so it's going to be a higher level math. Hopefully you guys are sticking with me here and doing all right, but recommend you do these 3.1 exercises and get some more practice, because especially now as we get to this more complicated stuff, the more practice the better. So until then, see you guys next time.